All right, we're back. We are still on page 5 of notes 24 of Calc AB, and in the last video, I said I didn't want to simplify it because I was just kind of being lazy. I did simplify it. I did get it right. The thing I neglected to talk about was the domain of this. So in this particular thing, if you look at the original function, x can't be 0, right? Because if x is 0, you're trying to divide by 0, and you can't do that. So we actually do need to think about it. Think about the slope field. The slope field has vertical asymptotes when x is 0. So we actually need to think about the domain. I'm going to throw in here that x actually, because in this given initial condition, x is greater than 0, I'm going to throw in that x has to be greater than 0. So I am adding that. I don't think you'd get dinged for that on anything, but it really should have been there. So let's take a look at the next one. So this one kind of has the same sort of problem where y can't be 0. So I think we're going to end up choosing a top or a bottom part of this curve if in the event that that becomes a thing. But let's take a look. So I'm going to separate and integrate. So I get y dy is equal to x squared dx. All right, so we separate. We're going to throw in some integral signs. On the left side, I get 1/2 y squared. I would put a plus c if I was just doing a general integral, but since there's another integral with its own plus c, I'm going to throw everything on the side with the independent variable, which is x. So here's 1/3 x cubed plus c. Okay. Now we're going to use our initial condition, which is here. So -3, so that's 9/2 is equal to c. That's just that. All right, so 1/2 y squared equals 1/3 x cubed plus 9/2. That's good, except we need to solve for y. So y needs to be a function of x. So we'll go up here, and I'm going to multiply by 2, get y squared is 2/3 x cubed plus 9. Okay, now here comes the big part. So I'm going to take the square root of both sides, and I get plus or minus 2/3 x cubed plus 9. But look at our initial condition. Our initial condition has y less than 0. So to finish this problem, we need to choose the branch that would allow y to be less than 0. Well, I'm going to say y, therefore, is the negative of the square root of 2/3 x cubed. So I should probably say therefore. Therefore, cubed plus 9. I believe that is our final answer on that. So there's definitely some kind of weird domain issue on this, but the domain issue isn't related to the differential equation. It's just related to this function has like a specific domain. Zero's in that domain, so I'm okay with it. Like, I don't need to think about the restriction unless it comes from the differential equation. If it's the natural domain of the function that causes a problem, so be it. And if the question asks me for the domain, I'll put it. Otherwise, I'm more than happy with this. I did have to worry about y being less than 0, though. That's a big deal. So when you get that plus or minus, you don't get plus or minus in your final answer. Like, can't happen. All right, let's try this. So we're going to separate. I'll get dy over square root of 1 minus y squared, which I kind of recognize because I memorized a lot of derivatives in my life. So we're going to integrate, integrate. All right, on the left-hand side, 1 over the square root of 1 minus y squared, that I recognize as arc sine. So this is going to be the sine inverse, or the inverse sine, or the arc sine of y is 1/2 x squared, and our plus c goes there. When should we try to solve for c? I don't really think it matters on this one, so I'm going to just solve it right now. So I look, this is my initial condition. So I'm going to find the particular solution that agrees with that. So if y is equal to 0, y is equal to negative 1/2 when x is 0. So I need to do the inverse sine of 1/2 is equal to c. All right, do I have those memorized is basically what I was going to say. I do. So for arc sine, sine inverse of x, I use this part of the unit circle, And so sine is 1/2, and that's like the y value. So it's going to be like here. And I know that that corresponds to pi over 6. So I know it's going to be pi over 6 is equal to c. All right, so how much work are we doing on this? I don't really know. There were no real restrictions initially, so like I don't really need to worry about that much. So we're going from here to here and here, both feed into this. And so we'll have the sine inverse of y is 1/2 x squared plus pi over 6. All right, I'm gonna take the sine of both sides because I have to solve for y, not solve for inverse sine of y. So I'll say y is equal to the sine of 1/2 x squared plus pi over 6. Crazy. And then, so I mean, technically from the original, y needs to be between -1 and 1. -1 and 1? 0, -1 and 1? Yeah, -1 and 1. But the range of this is -1 to 1 anyway, the range of our final answer. So I'm going to take this as my final answer. I kind of like overthink these a little bit, which I think is kind of good. I mean, you don't want to like, you don't want to paralyze yourself by overthinking, but like a little bit of overthinking is probably appropriate on these. All right, so this one looks like we have an extra step before we get to anything. So I'm going to say x squared minus 4 dy dx is equal to -xy. And then I'm going to divide through. So I would get -xy over square root of x squared minus 4. Now I'm going to separate, get dy over y is -x over root x squared minus 4 dx. All right, so that was a lot of work. I'm going to get a natural log here, so who knows where this will lead. So I have natural log of the absolute value of y equals, so you can do your u substitution on this, right? U is equal to x squared minus 4. So then I need a 2. First of all, in my mind, I'm just factoring that negative out. Like it's just in the way. I need a 2, so a 1/2. So I'm going to get -1/2. And then it's u to the -1/2. So there's going to be another 2. And then u to the 1/2. So x squared minus 4. And then a plus c. So if you do your u substitution, which I encourage you to do, I just like don't really like doing them. Like, and you can check this by like taking the derivative in your head. So it'll be like -1/2 thing to the -1/2 times 2x, and then the 1/2 and the 2 cancel, and you're back where you were. So it definitely worked, and I would encourage you to actually do the substitution. I just don't like doing it. And you don't really need to if you can like work your way through. All right, so oh, I'm definitely not solving for c yet. Oof, look at me. I got involved in talking about that, and I thought, let's skip a couple of steps, and we'll have that y is equal to a new c e to the negative radical x squared minus 4. I feel like this is not the first time we ran into a function that looks like this, which is good because you want to have run into everything at some point. Let's use our initial condition. X is √8 and y is equal to 3. So it's 3 is equal to c e to the negative √8 squared is 8. Well, there's a radical here. 8 minus 4 is 4. Okay, so that's 3 equals c e to the negative second. So c is 3 divided by e to the negative second, but 1 over e to the negative second is just e to the second. So I think it's 3e to the second. And then we can combine which steps? I'm going to combine this step and this step and end up with my solution is y equals 3 e squared e to the negative √x squared minus 4, but that can be rewritten as 3e to the, I'll say 2 minus √x squared plus 4. That's a gross answer. I don't know if that's right. I mean, like almost anything could be the answer to this. I believe this is correct. I think I should have put that Oh no, that plus 4 is inside the radical. Holy cow, I think I should have done a better job on that. There we go. Okay, so did we do this right? I don't know. Subtracted, divided. Oh my god, I put a weird radical in. There was no radical there. Crud. I think I should redo the problem. So I apologize, but why did I do that? Why did I put this radical in here? So that goes. How much of this can I salvage? And then at this point, this side is useless. So I got to cross all this out. Oh man, I wonder how many people are just like following along, screaming at the screen, like, don't do that. And also, my computer keeps me annoying about videos today, so I would redo it, but I'm just going to go with what we have. So this will be a little longer because I messed up. But that's all right, probably. I don't really know. All right, so what do we have here? I think this is right at this point. Subtract, divide, separate. Now we're integrating. All right, left-hand side is definitely all right. The right-hand side, u is x squared minus 4, which is actually the same. So there should have been a 2, a 1/2. So I think here we get negative 1/2 natural log of the absolute value of x squared minus 4. And then plus c. Okay. I apologize. That was dismal. My bad. All right. So what am I going to do here? Well, I'm going to show some extra steps. So I'm going to exponentiate and I'm going to skip some steps. So y equals, that c comes down as a new c, but I'm going to write e to the negative 1/2 natural log absolute value of x squared minus 4. Okay. So far, so good, I think. Again, we're doing this for the second time. Properties of logs here are going to come in. So let me write them up here. The first one is that, what is the first one? It's a times the natural log of b. I'll write it right on my face. A times the natural log of b is the natural log of b to the a. So I'm going to use that. And then e to the natural log of b is equal to b. I'm going to use both of those properties basically right now. So I'm going to take the negative 1/2 and bring it up as the exponent. So it'll be y equals ce to the natural log of, what to do? I'm going to make it 1 over the square root of the absolute value of x squared minus 4. Okay, so we got that. And then e to the natural log of blah, so I have y equals c times 1 over the square root of the absolute value of x squared minus 4. Okay, I'm going to solve for c now. So if I solve for c now using x is root 8, y is 3. I apologize this is taking so long. I mean, you know, I didn't plan to read the problem wrong, I guess. No, I mean, I don't guess. No one would plan to read a problem wrong. All right, so y is equal to 3, so I just get 3 equals, c is on top, 1 over square root of x squared is 8 minus 4, so 4. So that's 2. So I think c is 6. So I'm thinking that my final answer here might be 6 over the square root of the absolute value of x squared minus 4. Okay, so that's my temporary final answer. But this is a really weird function that actually has like a 3-part domain because x can't be 2 or negative 2. So let's figure out the domain. So I'll do it in a different color. So domain. So you can't be 2 or negative 2. Negative 2 and 2. But since it's absolute value, like it's the absolute value of x squared minus 4 is positive everywhere. So everything except negative 2 and 2 are in the domain. So the question is, where does radical 8 fall? Right? Because x needs to be able to be radical 8. So radical 8 is 2 root 2, which is like 2.8-ish, I guess. So it's there. So here I need to include x is greater than 2. I believe that this is my final answer on this question. I'm going to risk going to so the calculator is not playing well today. I'm going to risk going to the calculator and checking these. And when I do, I may not be able to come back to the notes, but hopefully I will. But you know, there's no way to be sure of that. So DE solve, and then it's y prime equals. And again, if this cuts out, I'm just going with it. I'm just going to post a, you know, kind of annoying video that doesn't have all the details, but that's okay. Let me just say goodbye to you now in the event that it does mess it up. So I get this, but you have to solve, and then you have to choose. So you choose the negative square root. So we got that one. DE solve y prime equals x times the square root of 1 minus y squared, and y of 0 equals negative 1/2 comma x comma y. Okay, and then we had to, so if I don't know if this is a risky thing. I took the sign, oh God, it was too risky. I should have subtracted, what should I have done? I should have subtracted, I used the wrong thing there. Jeez. All right, I'm gonna go back and fix that. And then DE solve, this is not my best video. Not gonna lie. Y prime equals negative x times y over the square root. This one might, why do I want it to be square root? X squared minus 4. If this one's wrong, I might just remake this video and nobody will ever know. Square root of 8 is equal to 3 comma x comma y. So we get 6 over, yeah, and then the calculator doesn't care about things like domain, which is kind of like a weird thing. But like, you know, there's nothing we can do about that. So I'm gonna try to go back to the notes. Last time I did this, it did not go back to the notes in the video. And that was a little depressing because it's like kind of a lot of work. But if it is going back to the notes right now, I am going to fix the answer to C, which, where did I mess it up? I messed it up when I plugged in positive 1/2. So that's where it all went wrong. So this should have been negative 1/2, which means in my work down here, I should have put the point like here and said that it was negative pi over 6. And so up here, this is actually negative pi over 6. So this is actually minus. This is actually like relatively easy to fix, maybe. Also, it's all dependent upon the video. Is the video picking this up? I don't know. All right, but we did it. So none of these were necessarily easy, but you know, other than me completely screwing up a couple times, I think we made it through. So I'm going to definitely end the video here, and I will be back in the next video to do even more of this. So I will see you then.